Inference Insight, always-on memory agent, what Google's new repo actually does. The project's own README describes it in one sentence. No vector database, no embeddings, just an LLM that reads, thinks, and writes structured memory. That's worth sitting with. Today's brief is about what that actually means, what this repo does well, and what you need to know before you take it seriously. Welcome to Inference Insight. Last week, a developer at Google Cloud published a project called the Always-On Memory Agent to the Generative AI repository on GitHub, MIT licensed. Built on Google's Agent Development Kit and Gemini 3.1 Flash Lite, runs locally with 3 commands. The headline claim in the README is that most AI agents have amnesia. They process information when asked, then forget everything. And this project gives agents a persistent, evolving memory that runs as a lightweight background process. The interesting part isn't the claim. The interesting part is how it pulls it off. Before I go into how it works, if you're an engineering manager, here's the frame. This is a working blueprint for a pattern your team can evaluate in half a day. The question it answers concretely is, what does it actually look like when an AI assistant remembers things across sessions, synthesizes across documents, and surfaces insights your team didn't explicitly connect themselves? Clone it, run it, feed it 5 real documents from a project your team is working on, wait for 1 consolidation cycle, ask a question it should be able to answer. You'll know within hours whether this pattern is worth a sprint investment, and the code is clean enough to adapt if it is. The approach is deliberately unconventional. No vector database, no embeddings. The system stores memories in a local SQLite database as structured text records. And when you ask it a question, the query agent reads all of those records and reasons over them directly. Not nearest neighbor retrieval, actual reading and thinking. That's the bet the project makes. And it's a real trade-off with real consequences in both directions. 3 agents do the work. The IngestAgent handles input. You drop a file in the inbox folder, or post to the HTTP API, or upload through the Streamlit dashboard, and within 5 to 10 seconds, the agent has processed it. 27 file types are supported: text, Markdown, JSON, CSV, images, audio, video, PDFs. For each one, Gemini extracts a structured record with a summary, a list of entities, topic tags, and an importance score. The multimodal support is more useful than it sounds. Drop a meeting recording in the inbox, and it gets transcribed and tagged. Drop a research paper, and it gets summarized. Drop anything relevant to a project, and the agent figures out what it is. The ConsolidateAgent runs on a timer, every 30 minutes by default. When it fires, it reviews all the memories that haven't been consolidated yet, looks for connections across them, generates cross-cutting insights, and compresses related information. The README compares this to how the human brain consolidates during sleep, not just storing what happened, but actively finding what matters across everything that happened. 2 separate documents pointing at the same problem get connected. An insight that neither document contained alone gets generated. That's the part that separates this from a retrieval augmented generation setup. The query agent completes the loop. Ask a question in the dashboard or via HTTP GET, and it reads all stored memories and all consolidation insights, then synthesizes an answer with source citations referencing specific memory IDs. The demo in the README shows it answering, "What should I focus on?" with prioritized recommendations that draw on consolidation insights as much as raw memories. You get synthesis, not just retrieval. Why no embeddings? Because at small to medium scale, an LLM reading everything and reasoning over it can produce better answers than similarity search over vector representations. Embeddings are efficient. They let you search millions of records in milliseconds. They're also lossy. The embedding may not have captured the nuance that matters for your specific question. When your memory count is in the dozens or low hundreds, letting the model read everything and think is both practical and often smarter. The project makes that trade-off explicitly. The README owns it, and Gemini 3.1 Flash Lite is the right model for always-on background work. Fast, cheap, designed for continuous throughput, not raw reasoning power. Getting it running takes about 5 minutes. Clone the repo, get a Google AI Studio API key, run pythonagent.py. The file watcher starts. The consolidation timer starts. The HTTP API comes up on port 8888. There's a Streamlit dashboard if you want a visual interface for browsing memories, uploading files, triggering consolidation manually, or running queries. The API is minimal and sensible. Query, ingest, list memories, consolidate on demand, delete a memory, full reset. This is the kind of project where the quick start actually works. Now let's talk about what to be aware of. Some of these are intentional design choices, some are genuine limitations of the current implementation. The distinction matters. The scalability ceiling is inherent to the no-embeddings approach. The QueryAgent reads all memories on every query. At dozens of memories, this is fast and cheap. At hundreds, it's still manageable. At thousands, you're paying for a large context window on every question, and latency starts to matter. This project is designed for focused, bounded use cases. A project-scoped memory layer, a team research brain, a personal assistant with a defined scope. If you know that going in, the trade-off is reasonable. If you're imagining a system that runs indefinitely across hundreds of users, you'll hit a ceiling. Consolidation is probabilistic. The ConsolidateAgent can find connections that aren't there, compress nuance away, or miss connections it should have made. And the current implementation doesn't give you a granular audit trail of what changed during a consolidation cycle and why. You can read the memories, you can read the consolidation insights, but if a consolidation cycle produces something wrong, understanding what happened means querying the SQLite database directly. That's acceptable for a prototype. It's something to solve before you rely on any output for anything important. SQLite is the right choice for local use and personal deployment. It is not the right choice for multi-user or concurrent write scenarios. The README lists memory.db as a file that gets created automatically, which tells you exactly what the project is optimized for, getting started, not scaling out. If you need this running for a team of 10 people writing memories simultaneously, you'll need a different persistence layer. Ingestion reliability deserves attention. The file watcher is convenient, but background processes fail quietly. If the IngestAgent hits an error on a file, there's no robust retry mechanism or dead letter path in the current implementation. The agent can behave as if it knows the contents of a file it never successfully processed. For personal use, where you're watching the dashboard, you'll notice. For anything more automated, add logging and observability to the ingestion step. And if you expose the ingest endpoint to untrusted input, the HTTP PI makes that easy to do accidentally. Adversarial content framed as a regular document can get stored as a memory and recalled at query time. The QueryAgent reads everything. A poison memory gets read too. For personal use on your own machine, this is low risk. For any networked or multi-user deployment, validate and scan incoming content before it reaches the ingest endpoint. The repo doesn't include that guard by default. So what is this actually for? The README's framing is a personal assistant with persistent memory. The architecture points towards something more useful for teams, a project-scoped knowledge layer that ingests the artifacts a team already produces, meeting recordings, design docs, research papers, decision notes, consolidates the insights across them, and answers synthesis questions on demand. The multimodal input makes that genuinely practical. Drop the artifacts in the inbox, let the agent run, ask a question that would normally require someone to remember 3 meetings from 2 months ago. The code is the right size to read, adapt, and build on top of if the pattern holds up for your use case. 3 things to take away. First, the no-embeddings design is a deliberate bet, not a gap. It trades scalability for reasoning quality at small scale. Understand the trade-off before you decide whether it fits your use case. Second, the ConsolidateAgent is the differentiator. Active synthesis across everything it knows, finding connections, generating insights that weren't in any single document, is genuinely different from retrieval. Watch a consolidation cycle happen and read what it produced. That's where the interesting behavior lives. Third, this is runnable code, not a concept. Clone it, run it, read agent.py. The consolidation prompt is the heart of the system, and once you've read it, you understand the whole thing. 2 things to do this week. First, run it with real content. Drop 5 documents into the inbox, meeting notes, a research paper, anything from a project you're actually working on. Wait for the first consolidation cycle, then ask a synthesis question. See whether the answer reflects something none of the individual documents said explicitly. That's the behavior you're evaluating, and you can't evaluate it without running it. Second, read the ConsolidateAgent code in agent.py before you build anything on top of this. The consolidation prompts tells you how the model decides what counts as a connection and what counts as an insight. Once you've read it, you'll have a clear opinion on whether it's doing the right thing for your use case. And that's exactly the question you need to answer before you invest in adapting it. So here's the one-sentence version if you need to hand this off. The always-on memory agent is a local, runnable blueprint for what it looks like when an AI assistant ingests your team's artifacts, consolidates the insights across them every 30 minutes, and answers synthesis questions by reading everything it knows. No vector database, no embeddings, just a model reading structured records and thinking. Half a day to evaluate, clean enough to adapt. The ConsolidateAgent is the interesting bit. See you next time.